You know, have you ever thought about our solar system not just as a place, but as a character with its own life story? It had this incredibly violent birth, a really dynamic life, and you know what? It has a definitive, quiet end. So today, we're going to explore that entire cosmic biography, from its very first spark to its final fade. So where do you even begin, right? How do you go from pretty much nothing, just cold, empty space, to a vibrant system of planets, moons, and a star? That's the big question we're diving into. And it all starts with, well, a giant cloud. And that brings us to the very first chapter of our story, the absolutely dramatic formation of, well, everything we know. And this is not a gentle process, not at all. It's a story of gravity, collapse, and some serious cosmic fire. The best theory we've got for how it all began is called the nebular hypothesis. And the idea is actually pretty simple. About 4.6 billion years ago, our entire cosmic neighborhood was just this vast, cold cloud of gas and dust, just kind of hanging out in space. Okay, so this is basically the cosmic recipe. First, something, maybe a shockwave from a nearby exploding star, gives the cloud a little nudge. It becomes unstable, and gravity just takes over. As everything falls inward, it starts to spin faster and faster, flattening out, kind of like a chef spinning pizza dough. The center gets so incredibly hot and dense that atoms literally start to fuse together, releasing a mind-boggling amount of energy. That's nuclear fusion, and boom, our sun switches on. Now, in the disk swirling around it, it's all about temperature. In the hot inner part, only rock and metal can condense, but in the colder outer regions, ices can form. And from there, it's just a cosmic game of demolition derby in reverse. All these materials start sticking together, growing from tiny dust specks to pebbles to boulders, and eventually to the planets we know and love today. So, the sun is born, and it immediately becomes the undisputed main character of this entire story. I mean, it's the gravitational anchor, it's the engine, it's the ruler of everything that comes after. And this number just says it all, doesn't it? It shows you just how dominant the sun really is. Pretty much everything else, all the planets, moons, asteroids, all of it, is just leftover rounding error. The sun is the solar system, making up 99.86% of all its mass. Its gravity is the law. And just to give you a sense of what's going on inside that massive star, get this. A little particle of light, a photon, is born in the sun's core. But that core is so unbelievably dense that this poor photon bounces around randomly for, on average, 170,000 years before it finally breaks free. So the sunlight hitting your face today? Yeah, it began its journey when our earliest human ancestors were first walking the Earth. Wow. All right, with the sun firmly in place, we can now meet the rest of the family, this diverse cast of planets that formed in that spinning disk of leftovers. And what you're going to see is that this family is really split into two very different groups. So you've got two distinct clans of planets. The inner terrestrial planets are the rocky worlds, Mercury, Venus, Earth, and Mars. They formed in that hot part of the disk where only tough stuff like metal and rock could survive. Then you go farther out, past something called the frost line, where it was way colder, and you find the gas and ice giants, Jupiter, Saturn, Uranus, and Neptune. They could grab all the lighter stuff, like hydrogen, helium, and water ice, which let them grow to absolutely enormous sizes. Let's take a quick look at our famous neighbor, Mars. It's a world of extremes, from its icy polar caps to the biggest volcano in the entire solar system, Olympus Mons. But honestly, the most exciting part of its story is the clues it's left behind, evidence that it once had flowing rivers and maybe even oceans. Figuring out what happened to all that water is one of the biggest mysteries driving us to explore the planet today. And then there's the king, Jupiter. This thing is a totally different beast. It's basically a failed star made of hydrogen and helium. It's got that famous Great Red Spot, which is a storm bigger than our entire planet that's been churning for centuries. And its moons, they're like a whole other solar system, with incredible worlds like Europa, which we think has a huge liquid water ocean under its icy shell. That makes it one of the top places to look for life beyond Earth. And to put its size into perspective, Jupiter is more than twice as massive as all the other planets in our solar system combined. It is a true giant, a bully that pushes everything else around with its immense gravity, and it probably shaped the orbits of all the other planets. Now, Saturn, of course, is famous for its gorgeous rings, but I think its coolest feature is its density. The fact that it's so light it could float in a giant bathtub isn't just a fun party trick, it tells us something really important about how it formed. It was so far from the sun that it could just gobble up enormous amounts of the lightest gases, hydrogen and helium, which puffed it up into this beautiful, low-density giant. And then you get to the system's total oddball. While most planets spin kind of like tops, Uranus is rolling on its side. It was almost certainly knocked over by a massive planet-sized collision way back in its past. And that tells us that the early solar system wasn't some peaceful, orderly place. It was a chaotic shooting gallery where entire worlds were smashing into each other.
But our tour doesn't stop with the 8 main planets. Oh no. Beyond them lie these vast, cold, and super mysterious outer reaches of our solar system, and they're filled with countless other objects left over from the very beginning.
This is where we run into the dwarf planets. So what's the big deal? Well, they're big enough for their own gravity to pull them into a nice round shape. But, and this is the key, they haven't cleared their orbits of all the other junk. They live in really crowded neighborhoods. And this exclusive club, which famously includes Pluto, also has members like Ceres, which is actually the biggest thing in the asteroid belt. This chart really helps lay it all out. First, you've got the asteroid belt, which is basically a bunch of rocky rubble that Jupiter's gravity kept from ever forming a real planet. Then, way out past Neptune, you hit the Kuiper belt. This is a huge icy realm where Pluto and other dwarf planets hang out. And then, surrounding the whole shebang, is the hypothetical Oort cloud, a giant sphere of icy bodies that we think is the source of a lot of our comets. So, we've seen its birth and we've toured its vibrant life. But you know, every life story has to have a final chapter. Now, we're going to look billions of years into the future to see how it all ends. The future plays out on a timescale that's just hard to wrap your head around. Right now, things are pretty stable. But in about 1 billion years, the sun will get brighter and hotter, eventually boiling away Earth's oceans and ending life as we know it. Fast forward to 5 billion years from now, and the sun will run out of its main fuel and swell up into a red giant. And it will very likely swallow Mercury, Venus, and maybe even Earth. And then finally, it'll shed its outer layers and collapse into a tiny, super dense core called a white dwarf, the glowing ember of a once mighty star. The planets that are left will just be left to orbit this cinder in the cold and the dark. So the takeaway here is that this entire cosmic story, from a brilliant cloud of gas to a system just teeming with worlds, will eventually come to a close. Its fiery, chaotic birth will be answered, in the end, by a cold, silent fade to black. And that leaves us with one final, unavoidable question. The stage where our entire history, all of human existence, has played out, it's all going to be erased one day. So what story will we, its only known storytellers, have left for the universe to maybe find? What's our legacy going to be?